All right, today we're going to talk about the single most powerful engine shaping our future. And, more importantly, why our brains are just completely blind to how it works.
So, what do these two things have in common? I mean, on the surface, they seem like total opposites, right? One is this amazing story of infinite creation, the other, a kind of grim story of finite decline. But what we're going to see today is that they are actually two sides of the exact same coin, a powerful and visible, and honestly, a deeply misunderstood force. And the answer to that big question, well, it's right here in this quote from the physicist Al Bartlett. See, the key isn't really about technology or economics. Nope. It's about a single, simple piece of math that basically runs our world. And the crazy part? Our brains are just not built to get it.
Okay, so if we're going to try and grasp this thing, we need a tool. And the good news is you don't need a PhD in math or anything. We're talking about some simple but pretty startling arithmetic.
Yeah, I know. Exponential function sounds super intimidating, right? Like something out of a textbook. But Professor Bartlett broke it down really simply. It's just a fancy name for plain old steady growth. You know, like when something grows at a constant 5% or 7% a year. It sounds so small, so manageable, almost harmless, really.
And here's the little mental shortcut he gave us to really see the power hiding in those small numbers. It's called the rule of 70. It's super easy. You just take the number 70 and you divide it by whatever the percentage growth rate is. And boom, that's how long it takes for that thing to double. So let's say your city's population is growing at 7% a year. You do 70 divided by 7, that's 10. That means the population will double in just 10 years. It's so simple, but the consequences are just huge. Okay, to see just how weird and counterintuitive this all gets, let's try one of Professor Bartlett's famous riddles. Picture this. You've got a bottle. At 11 a.m., you put one single bacterium inside. And these little guys, they double in number every minute. By exactly 12 p.m., noon, the bottle is completely 100% full. So here's the question for you. When was the bottle only half full?
Now, your gut probably says 11:30, right? That's what most people think. But that's our linear brain trying to make sense of things. Remember, they double every minute. So if it was full at 12, it must have been half full just 1 minute before that. The answer is 11:59 a.m. But here's where it gets really crazy. Look at what was happening in the minutes before that final moment. Yeah, at 11:59, it's half full. Go back one more minute to 11:58, it's only 25% full. Now let's jump back to 11:55 a.m., just 5 minutes before it's totally full. The bottle is only 3% full. I mean, to anyone looking at it, it would seem basically empty.
And this is the whole point. Think about it. At 11:55, with 97% of the bottle looking like, as Bartlett used to say, wide open space just yearning for development, would you have had any clue there was a problem? Would you have seen a crisis coming? This little riddle just perfectly shows our collective blind spot. We're just not wired to see an exponential threat until we're literally 1 minute from midnight. Okay, so now let's take that exact same logic, but instead of bacteria in a bottle, let's apply it to something very real and happening right now. The explosive growth of artificial intelligence. And look, this isn't just some abstract theory. This is a quote from Julian Schrittweise, a top researcher at Anthropic who actually worked on DeepMind's famous AlphaGo project. He says that all this talk you hear in the news about an AI bubble feels totally disconnected from what's actually happening inside the labs. As he says, it's just very hard for us to intuitively understand these exponential trends. The story of AlphaGo is the perfect example of this insane acceleration. I mean, in 2016, it beats the world champion by learning from human games. Big deal, right? But then, just 1 year later, AlphaGo Zero comes along and doesn't even need humans. It teaches itself the entire game from scratch. And then, a year after that, AlphaZero masters not just Go, but chess and shogi too. You see? Every step isn't just a step, it's a giant leap, bigger and faster than the one before it. So if you just draw a line from that trend, Schrittweise thinks that by next year, we could have AI agents that can work all by themselves for a whole day. Then by late 2026, a model could match human experts across a ton of different jobs. And by 2027, they could be outperforming human experts on the regular. We are not at 11:55 a.m. on this curve, folks. We are way, way closer to noon. Now, the upside of this curve, it's just breathtaking. Schrittweise poses the question, what happens when you make everyone in society 10 times more productive? I mean, what kind of abundance could we achieve? We're talking about advancing science, curing diseases,
maybe solving problems we thought were impossible to solve. So that's the exponential curve of creation. It's an incredible, incredible force. But what happens when that same relentless doubling math gets applied not to something digital, but to the physical, finite resources of our planet? And that brings us to our second curve, the curve of consumption. And it's driven by the exact same unforgiving math. And this is where that little riddle stops being a riddle and starts being reality. That bacteria in a bottle problem, it's not just a clever thought experiment. Professor Bartlett argued that it is a direct model of our global economy, where the bottle is, well, planet Earth. And again, this isn't some guess about the future. This has already happened. For a huge chunk of the 20th century, global oil consumption grew at about 7% a year. Remember our rule of 70? That's a 10-year doubling time. President Carter pointed this out decades ago. It meant that in the 1950s, we used more oil than in all of human history combined up to that point. And then, in the 1960s, we did it all over again. In a single decade, we used more than all the growth that came before. It's mind-boggling. This is how our exponential blind spot gets us into trouble. It makes us fall for these dangerously misleading claims. For example, you hear people say, "Oh, we have enough coal for 500 years." But, as Bartlett showed, that's only true if we stop growing our usage. Zero growth. The second you add even a pretty modest 4% annual growth, that 500-year supply, it's gone in just 75 years. Let's apply our bottle analogy one more time, but to world oil reserves. You see this same scary pattern. At, say, 2 minutes to midnight, our reserves would feel endless, like 3 times more than everything we'd ever used. But then, just one doubling later, 1 minute to midnight, what's left is only equal to what we've already burned. And then at 12, the bottle's empty. But wait, people always say, what about new discoveries? We'll just find more. And this, to me, is the most powerful and, frankly, terrifying part of the whole thing. Let's go back to our bacteria. At 11:58, they make a huge discovery, 3 brand new empty bottles. They've just quadrupled their entire world. They must be saved, right? But the doubling doesn't stop. At 12, the first bottle is full. By 12:01, the second one is full. And by 12:02, all 4 are gone. That massive world-changing discovery, it only bought them 2 extra minutes. So where does that leave us? Well, it feels like we're living between these 2 gigantic, world-shattering curves. And both of them are being driven by the exact same deceptive math that our brains just can't seem to get a handle on. When you boil it all down, it comes to this. Our brains are just not wired to understand the power of steady growth, what they call the J-curve. That's our biggest blind spot. It's why we're always so shocked by how fast AI is moving. And it's also why we seem so calm and complacent about the hard math of running out of stuff. We are literally caught between 2 massive exponential curves, one of creation and one of consumption. Both of these curves are speeding towards their own midnight moment. One promises a future of incredible abundance, while the other points towards irreversible scarcity. The math, well, the math doesn't care what we think. It's relentless. The only thing that can change is us. The only question is whether we, the bacteria in this bottle, can finally learn to see what time it is. Can we finally understand this curve before we go right over the edge?